rows with target sum. So for this problem, we are given 3 integers. So the first integer is n. So this means the number of times we're gonna roll a dice. Yeah. So the second number k, this means the range of the dice. So for example, if k equal to 6, it means the range of the dice gonna be from 1 to 6. And this n, it means we're gonna roll the dice one time. And the target is just we're gonna check the sum of all result. If it is equal to the target, so we're gonna call it one time. Yeah, we just need to return the number of times, as the number can be a really big number. So we're gonna return modular this number. Yeah. So how are we gonna solve this problem? And we should also know that the total time gonna be k to the power of n. So for example, if k equal to 6, n equal to 1, so 6 to the power of 1, it means if we roll a dice, the dice is from 1 to 6, so how many different ways? So it's gonna be 6. And for the second example, k to the power of 2, it's gonna be 36. Yeah, so this means if we're gonna roll the dice 2 times, so how many different combinations? It's gonna be 36. And we should know that 3, 2, 3, and 3, 2, it's gonna be two different times. Yeah, because the first dice is 2, the second dice is gonna be 3, the first dice is 3, second dice is gonna be 2, and this is different. Actually, this problem we're gonna call it a group knapsack problem. So for the group knapsack problem is that we are giving a pattern. So this is going to be the index. So the index is going to be the number of times. So for example, if we have 2 times, so the index is going to be starting from 0, and the next index is going to be 2. Yeah. So this means the number of times. So if the times equals to 2, it means we need to go out of the DFS, because we're going to use a DFS to solve the problem. Yeah. So this is going to be the times. So for each of the time, we're going to choose a number. So this number is going to be between 1 to k. So here in this example, it's going to be between 1 to 6. And for the second one, it's going to be 1 to 6. Yeah. So this means some number is inside a knapsack. But we are not only have one knapsack, we have k knapsack. So this is we're going to call it a group knapsack. So inside each of the knapsack, we can choose a number, and we have several knapsacks. Yeah, we can understand it maybe like this. Yeah, this is also 1 to 6. So for each of the time, we can choose a number between 1 to 6. Maybe we're going to choose a number 2. Yeah, or maybe we're going to choose a number 3, because there's only one time. If we choose a number 3, so there's only one time. But what if the target equal to 7? Maybe for the first, we only have 2 times. Yeah, maybe first time we're going to choose 2, the second time we're going to choose 5, or maybe first time 5, the second time going to be 2, and how many different ways in total it's going to be 7. Yeah, so definitely we're going to solve this problem by using the group knapsack. So this means still we're going to understand the problem as a knapsack, but for each of the time we are not doing something like select or not select. We have to select a number between a group. So the group is going to become from 1 to 6. We have to choose a number. Yeah. So for the next time, we have to choose a number between 1 to 6, and we just need to check how many different ways. Yeah. Now let's just start coding. I'm going to prepare a mod. It's going to be 10 to the power of 9 plus 7, and then I'm going to start the DFS. So I'm going to prepare index I and the target. So the index I is the number of times. Yeah. So if the target is more than the target, basically it means it is not possible. So we're going to return 0. It means 0 times. Now we're going to check this I. If the I equal to n, it means it is the number of times. Yeah. If I equal to n, so we're going to return 1 time. This one going to be a valid answer. So if this t equal to the target, so otherwise we're going to return a 0. Now we're going to check how many different ways in each of the group. So how many numbers in each of the group? We're going to use a j. So for j in range from 1 to 7. Yeah, because for each of the time we just need to choose a number between 1 to 6. So here we're going to use a range 1 to 7. And we're going to accumulate all the possible results. So from the beginning, the result is going to be 0, and then we're going to accumulate all the possible results. So it's going to be DFS with I plus 1. It must be the next. Yeah, because for each of the time we have to choose a number from the group, and then we have to move to the next group. Yeah, And here we're going to update this t plus this j. This is the total sum. So if the total sum equal to the target, we're going to count it as 1, otherwise it's going to be 0. And finally, we're going to return the result modular the mod. And finally, we just need to call the function. It's going to be starting from 0, and the total number going to be 0 from the beginning. Yeah. Or you can write it differently, or you can start from the target. But I think it is the same. But from 0 to 0, this is more easy to understand. Now let me just run it to have a check. It seems we can pass for some testing case, but we cannot pass for all testing cases. Yeah, let's just check the last one. For the last one, we return a 0. Yeah, this means it is not 1 to 7. It is a k plus 1. Yeah, we have to use this k plus 1 because this k can be a different number. Now let me just run it. Yeah, and submit it. Yeah, now as you can see, it works and it's pretty fast. But we need to analyze a little bit about the time complexity. So for the I, and it's going to be the number of n, it's going to be 30. And for this t, it's going to be target, so it means the 30 gonna times 1000. Yeah. And we also need to use this k, and this k gonna be 30. So the final time complexity gonna be 9 times 10 to the power of 5. So this gonna still be a small number. That is why it is so fast. So I think that's about it. Thank you for watching. See you next time.